Today what we're going to learn is matrices, like matrix. This is not really, this exercise, okay, it's nothing to do with transformation yet. Okay, we just learned what a matrix was, what's the addition, subtraction, calculation for matrix, and we will combine matrix knowledge into transformation knowledge. Okay, so this exercise is nothing to do with transformation yet. It's pure calculations and know all this name of matrix. So what is a matrix? Matrix is a rectangular array of numbers arranged in rows and columns. Okay, so for example, this one I have like 4 rows and 5 columns. You have numbers, like 20 numbers in total. Okay, 4 rows, 5 columns, you have 20 numbers in total. This is like you put numbers in that box. So what is called an entry? Entry is, okay, all the numbers inside this box is called an entry. Okay, so we have 20 entries there. So for example, we have 20 entries in the matrix A. So give your example for a matrix, I can have 1, 3. That can be a matrix. I have 2 rows and 1 column. Okay, I have 2 rows and 1 column. I just arrange number in this particular way. So why we arrange that in this way, I will explain that later. But that's first of all, you know what is a matrix. This is a matrix. I have 2 rows and 1 column. Or I can have this matrix. Okay, I have 2 rows and 2 columns. 1, 2, 3, 4. Okay, so all the place needs to be filled with numbers. Okay, we can't have what? I can't have this. Okay, I can't missing any number in this row and column. I can put a 0 here, but I can't make here empty. Okay, that's wrong. We must have fill all the entries with numbers. Okay, every single spot needs to have numbers. Okay, and next one, 3 is the capital letter can represent a matrix. So I can say this matrix is called the matrix A. Okay, A is that matrix. I can say B is that matrix. So I can say matrix A, matrix B, and it refers to this one and that one. Okay, after you represent this matrix by a capital letter, you give a name to it already. Like this matrix name is named A. Okay, A. So matrix A, if I want to talk about this number 3, okay, in matrix A, I want to talk about the number 3. Well, if you have many rows and many columns, I can use a way to talk about, for example, there's many numbers here. People can't find which 3 you talk about. There's many 3s in the matrix. So I can refer to which row, which column for which particular 3 you talk about. And I can use a small letter A to represent the elements, okay, or say the entry. So entry at which position? The row first is at row 2 and column 1. Okay, lowercase a is the lowercase of the name. Okay, you use a capital A to represent that matrix. The lowercase a is represent the entry. And which entry we talk about? We talk about the entry in row 2 and column 1. So that entry equals to 3. Okay, that entry equals to 3. It can help you to locate what number you talk about. So for example, this one, I can say B2 2 equals to 4. Okay, row 2, column 2. Okay, which is the number 4. So I can use lowercase and the numbers at the bottom to talk about the particular entry. Okay, the next thing is very important, is the dimension. Okay, it's the dimension. Or other name we have is the order or the size. Okay, the dimension of the matrix, the order of the matrix, or the size of the matrix. They are talk about the same thing. So what that is you need to indicate what the matrix, what's the size of the matrix basically. How many rows are there and how many columns are there. It's talk about length and width basically. So we talk about the number of rows first. Okay, how many rows do we have? For example, this matrix A given in example 5, you have 3 rows. So you write the 3 first. And you see how many columns are there. There are 2 columns, so you write the 2 here. You make a times in between. So the order of this matrix is 3 times 2. But do not equivalent that equals to 6, okay? Do not say the order is 6. The order is not 6. The order is 3 times 2 matrix. Okay, same as a row 3, column 2. Because when you say a 6, I don't know what the 6 coming from. 1 and 6, 2 and 3, 3 and 2, 6 and 1. I don't know which combination. So you don't make it equals to something. The order is just 3 times 2. And as another example, like lowercase a to row 2, column 1. Okay, row 2, column 1. So the cross is at -1. So the number is -1. Order is a 3 times 2. Okay, if I read this one, what's the order of this matrix? Or say dimension? What is it? 2 times 3. Okay, 2 rows and 3 columns. So I have the dimension or order or size as 2 times 3. If you really make it equivalent to 6, the 6 represent how many entries do you have? Okay, how many entries do you have? Equals to 6, there are 6 numbers in this matrix. Alright, now let's talk about the operation for matrix. Okay, the operation for matrix. What we can do is we can add matrix, we can subtract matrix, we can times matrix. What else we can do? We can time a scalar factor to the matrix, but we can't divide matrix. Okay, we don't have matrix division. We can't divide A and B. We can times them, we can add them, we can subtract them, we can times the number in front of them. 4 things we can do, but the only thing we could not do is divide them. But okay, for number addition, subtraction, multiplication or division, there's no restrictions. Oh, except like I can't divide by 0, but I can always add 2 numbers. I can always subtract 2 numbers. A matrix is a little bit special. Okay, what is special? You cannot, well, when you add, subtract, times, there's all restrictions. Okay, you have restrictions to addition, subtraction, and multiplication. Let's have a look at, before that, we want to talk about when the 2 matrix will be equal. Okay, when you can say matrix A equals to matrix B. It's very easy. Basically, copy paste. You copy the first one, paste it, they are equal matrix. Otherwise, it's not same matrix. Okay, for example, A and B, they are not equivalent, because even though you have the same size, you have the same number as entries, but the entries is not at the corresponding place. Okay, not like the corresponding place do not have the same value. They are not equal matrix. So basically, copy paste means they are equivalent. Otherwise, it's not equivalent. Doesn't really similar to numbers like 2 and 5, 2 plus 5 and 5 plus 2, they are equivalent. But for matrix, it won't be like the case. So when you swap the order, the matrix won't be the same. Okay, when you swap the order of the entries, then the 2 matrix will not be the same. So A is not equivalent to B. All right. Addition and subtraction. As I mentioned, you have restrictions to add and subtract to matrix. It's very easy to do addition and subtraction. So what's the restriction? 2 matrices must have the same order or same dimension or same size. Then they can be added or subtracted. 3 times 2 and 2 times 3, that's not the same order. Okay, 3 times 2 and 2 times 3, they are not the same order. Same order means 3 times 2, 3 times 2. 1 times 1, 1 times 1. 2 times 2, 2 times 2. They are same order. But 2 times 4, 4 times 2, they are not the same order. So only same dimension matrices can be added or subtracted. Okay, requirement is same dimension for addition and subtraction. So another thing is matrix A plus matrix B will be same as matrix B times matrix A, which is very nice. Okay, that's the only nice thing for matrix, I think. A plus B equals to B plus A is the similar to number addition. Why we have this? You think it might be silly. A times A plus B must be the same as B plus A, but it's not that interesting when we do a multiplication. A times B will not be the same as B times A for matrix. So addition and subtraction, or subtraction can't be the same. A minus B not same as B minus A. Addition, you can swap the order, but when multiplication, you can't swap the order. All right, let's do the addition. How do we add to matrix? Well, value A, find the values of A plus B. So for A plus B, we have 1, 2, 3, 4 plus 2, 4, -3, and 1. Okay, how do we add it? We add the numbers at the same place and write it at the same place. So row 1, column 1, row 1, column 1, you add them. That will be 3. 2 and add -3. Again, 2 add -3. They are at the same position. We write it at the same position as well. You have a -1. Another symbol. What symbol I should have? Maybe that. That's a 7. And the last place is a 5. Okay, easy to do addition. Easy to do addition. Okay, now I want you to find A minus B and B minus A. Same as addition. Okay, same as addition. You just subtract the number at the same spot and write it at the same spot for the answer. Okay, find A minus B and B minus A. When you finish, you can have a look at the answer. You should easily get this. Same, the number at the same position, at the same corresponding place will be add or subtract according to the requirement. And you still write the number at the same spot. And you can see A minus B and B minus A, what's the relationship? You just minus every single thing in, like for every single number, like 1, 1, -5, -3. Alright, so that's addition and subtraction. Very easy, but there's restrictions. Not any two matrices can be added together. Only same dimension matrix can be added together. Okay. If we can keep moving. Yes? Oh, yep. Okay, multiplication. Okay, when you multiply a factor to the matrix, okay, you see this 3 times the matrix, like we can say that's a 3A. Okay, 3 times the matrix. So we basically, well, there's no restriction to that. Okay, there's no restriction to that. You can always time a scalar factor for a matrix. Okay, any matrix can be times by a scalar factor because you just simply enlarge everything in the matrix by that factor. So the 3 will times by every single number and you get a new matrix. Okay, you get a new matrix. That's very easy to do. Okay, that's very easy to do. You can just times every, well, if the factor is outside, it's a multiply a factor. So all the entries needs to be enlarged by the same number of times. So we have 6, -3, 3, and 0. Okay, let's have a look at example 2. So find the matrix X such that 2A plus X equals to B. Same as number, okay, same as number. 2A plus X equals to B. Let's write that down first. 2a plus x is a matrix equals to B, which is another matrix. Okay, 2a plus x equals to B. So I'm looking for x. You can treat this as number. Okay, I can treat this as number. So looking for the value of x. First of all, I can enlarge the scalar factor here. 6, 4, negative 2, and 2 plus x equals to 0, negative 4, negative 2, and 8. So x will equals to 0, negative 4, minus 2, and 8. Subtract 6, 4, minus 2, and 2. Matrix, sometimes when you do addition, subtractions, or times a factor, it's very similar. It's the same as number calculation. Okay, same as number calculation. Only when you do multiplication, it's a little bit different. Okay, so when you add or subtract or times a scalar factor, it's all the same. Only when you time two matrices together, it will be different from the number calculation. So x here will equals to negative 6, negative 8, 0, and 6. Okay, 0 minus 6 is minus 6, minus 4 is minus 8, minus 2 minus negative 2 is a 0, and 6 minus 2, 8 minus 2 is a 6. Okay, that's what we have for x. So same as number, we're solving for x, we use b to subtract to a. Okay, b subtract to a. Alright, last thing we'll do, multiplications of matrices. Okay, multiplications of matrices. This multiplication is different from this multiplication. This multiplication is the matrix times the real number, like a scalar factor. We just enlarge everything by that scalar factor. But the number 9, what we mentioned here is the matrix times matrix. Okay, A times B. Okay, it's very complex. Okay, it's very complex. You need to test whether two matrix. It's not all the matrix can be times together. Just like addition, not any two matrix can be added together. So how do we check whether they can be times together or not? Let's do this. If you want to times A by A and B, so the order is important. Which one in the front, which one at the back is very important. So if you want to use A times B, we write the order of these two matrices at the bottom first. Okay, we write the order of that matrix at the bottom first. So, well, tell me any order. Like anything, give me an assumption, like what order you like for A. Anything. Give me a dimension. 1 times 2. Okay. We can have a matrix 1 times 2 here for this dimension. Okay, any order. Give me another dimension for B. 2 times 3. Okay. I think someone on purpose give me a nice number. Okay, so how do we check it? We write that in order. Okay, A and B. Row column, row column. So what we need to check is the middle two number. Okay, those two. The column of the first one and the number of rows for the second one. If they have the same number, you can times them together. Okay, if they have the same number, then you can times them together. If they don't have the same number, you can't times that together. Because I just use the same example here. Okay, I use the same example here. If I use B times A. If I use B times A. So again, same thing. We use dimension. Okay, dimension for B is row 2, column 3. Okay, 2 times 3. That's the dimension for B. And want to find the dimension for A is 1 times 2. Okay, 1 times 2. We check the middle two number. They are not the same. Those two cannot be times together. Okay, those two. Well, I can times A and B, but I can't times B and A. How interesting is that? It's not the same as number calculation. Well, 1 times 2 is the same as 2 times 1, but for matrix, it's not the same. A times B, you can do it. B times A, well, sorry, you can't do it. So you can't swap the order. Not always like this, okay? Sometimes A times B is fine, B times A is fine as well. It really depends on the middle two number. Well, for example, you have two matrix 1 times 2 and 2 times 1. Okay, two matrix like this. Well, when you swap them, you still can times it. Okay, the middle two is still the same. So sometimes A times B and B times A can be operate at the same time, but the answer won't be the same. Okay, the answer won't be the same. Even though A times B is fine, B times A is fine, but the final answer might be different. 90% of time will be different. If it's the same, it's by coincidence. Okay, it's because it's all calculated by a different way. It's calculated by a different way. All right. How do we do them? Okay, how do we do them? Let's try which one? Let's try number 1. Okay, let's just try 1. Find the value of A times B. Okay, A times B. Matrix A is a 2 times 2 matrix. B is a 2 times 2 matrix. The middle two numbers are the same, so I can operate this. Okay, you need to check it before you start calculation. So you can do that. You can do that. So if you can do that, I write it here. So A times B, right? A times B equals to 1, 3, 4, 2 times 5, 1, 6, 3. Okay, two matrix, we write in that way. Well, the way I like to do it is circle it. Well, it can be quite messy, but like that's very easy for me to think, because I will circle the row for the first matrix. Okay, always circle the row for the first matrix and circle the column for the second matrix. Well, it doesn't matter how many rows you have, just always circle them. I think the worst case they will ask you to do is 2 times 2 matrix. They won't ask you to do 3 times 3 matrix and times another 3 times 3 matrix. This is the most complex case you might have, like to do it by hand. Okay, so 2 times 2 matrix times 2 times 2 matrix is the worst case you might have to do by hand. We always circle the row for the first one and circle the column for the second one. Okay, if you're not fluent doing this yet, we can label row 1 and row 2 and label column 1 and column 2. Okay. The middle two number must be the same in order to do the calculation, right? You're in charge of opening the door and close the door all the time. Okay, so let's say those two can be evaluated, and then we have a matrix equals to C. So what's the dimension for C? The dimension for C will be those two numbers. It's a 2 times 2. Okay, what has been left? 2 times 2. I'll give you another example for this one. This matrix, A times B, 1 times 2, 2 times 3. The answer C will be a 1 times 3 matrix. Okay, this number and this number. So it will be a 1 times 3 matrix. So you can predict what's the dimension for your solution as well when you do the multiplication. So that's a 1 times 3 matrix. So according to what we have here, we will have a 2 times 2 matrix, right? Because those two the same, this one and this one will become a 2 times 2 matrix. So my answer will be a 2 times 2 matrix. Okay, that's the teaching. Okay, you don't need to do that when you do it. So I know what I will have. I know I'll have 2 times 2 matrix. Looks like this. Okay, remember every row needs to meet with every column, but row won't meet the row. Row will go to meet the column. Okay, every row needs to meet every column. So now, what's the full combination we'll have? Row 1 and column 1, they will meet together. Row 1, column 2, they will meet together. Row 2, column 1, they will meet together. And row 2, column 2, they will meet together. That's all the combinations we'll have, right? So that's the full spot. Okay, that's the full spot what we'll have. Okay, let's see row 1 meet column 1 first. If you row 1 to meet column 1, the answer needs to be right at row 1, column 1 as well. Okay, that's your answer spot. That's why I label row 1, row 2, column 1, column 2. Your first row meet with the first column. This needs to be at the row 1, column 1 place. So how do we do the operation? The first number times the first number, the second number times second number. Well, if you have the third number times by the third number, and you add all your answers together. So basically what we have is, well, remember you're dealing with row 1 and column 1 now. In row 1, the first number meet column 1 first number is 1 times 5. Second number meet second number. Okay, you're dealing with row 1, column 1. So second number 3 times 6, and you will add them. Okay, you will add them. Okay, now, well, for example, I decided to use row 2 to meet with column 1. Okay, I meet row 1 and column 1 already. Now I want to use row 2 to meet column 1. Okay, where's row 2, column 1? Row 2, column 1 is this spot. So your answer will be at that spot. Okay, if you use row 2, column 1. Okay, row 2, column 1. So it will be, the answer will be at row 2, column 1. So it will be at that spot. So first number meet with first number, 4 times by 5. Well, remember you're dealing with this one and this one. And then the second number will times with second number, and you add them. That's the place for the row 2, column 1. Well, if I want to use row 2 and column 2 to meet, okay, row 2, column 2 to meet, answer will be here. Okay, answer will be here. So row 2, column 2, 4 times 1. Plus 2 times 3. Okay, first number times first, second number times second. And the only thing we haven't done is row 1, column 2. So use row 1 and column 2 to meet. So we have 1 times 1 plus 3 times 3. Okay, first number times first, second number times second. If you have third number, third times third. Okay, let's see what the solution is. 5 and 18 is a 23. 20, 12, 32. 1 and 9 is a 10. 6 and 4 is a 10. Okay, so that's the answer for A times B. That's the answer for A times B. Okay, I'll do another example for you. Well, I haven't done B times A yet, but let's see example 2 first. Okay, times a different thing. I also find the value of A times B and B times A. A times B. Okay, let's write it out first. Okay, the dimension for the first matrix is a 2 times 2. The dimension for the second matrix is a 2 times 1. Okay, the middle two numbers are the same. We need to check first. If they are not the same, you can't do undefined. But if the same, I can keep going. And the solution, okay, your answer will be a 2 times 1 matrix. Okay, will be a 2 times 1 matrix. The two number left, the first one and the last one, 2 times 1 matrix. Row 2, column 1. Don't lock it, just like that. So the answer will be 2 times 1 matrix. Now, same method I will do. I will circle the row. First one we circle the row, and second matrix will circle the column. There's only one column. Don't lock it. Okay, we have row 1 and row 2. And this one is called a column 1. There's only one column, so column 1. Okay, every row needs to meet with every column. So row and row won't meet, column and column won't meet. So row 1 needs to meet with column 1. Okay, row 1 needs to meet with column 1. And the answer will be right at row 1, column 1, which is the top. So first number times first number, 3 times 1. Second number times second number, 2 times negative 1. And we'll add it. And the second one is row 2 needs to meet with column 1 as well. So it's at row 2, column 1. So it's this place. So first number times first, add second number times second. Okay? And the answer will be 3 minus 2, which is a 1. Minus 1 plus minus 1 is a minus 2. So the answer is 1 minus 2. So you have a row 2, column 1 matrix. You have a row 2, column 1 matrix. Okay, now we try B and A. Okay, B is a 2 times 1 matrix. A is a 2 times 2 matrix. They are not the same. So undefined. Okay, I can't work. Undefined. I can't times B and A together. I can't times B and A together. So that's what I said. A times B is not equivalent to B times A. You can see that. Even this one can evaluate, this one can't evaluate. So it's undefined here. Any questions so far? Okay, I want you to use the rest of time to find in the first example, first question, what's B times A? Okay, what's B times A? And for the third example, find A squared and X squared. Well, some of them you might can't evaluate. Okay, these 3 questions: A squared, X squared, and B times A. Okay, use the rest of time to finish that. And if you finish, you can start doing some exercise for E. We can check answers after maybe 15 minutes. Okay, for example 3 part 1, like we miss B times A. We check B times A. We can times it together because the middle 2 numbers 2 and 2. So I can times those 2. If you do the row 1, column 1, row 2, column 2, row 1, column 2, and row 2, column 1 thing, we can find the 2 times 2 matrix, and we have the answer 9, 17, 18, and 24. Okay. If you do have the different answer, please let me know. Maybe I do some wrong calculations here. Okay, that's the first one, B times A. And well, second question we have done it, and the third one is A squared. So what's the A squared? A squared is A times A. Okay, A squared is A times A. Because A is a 2 times 2 matrix and A is a 2 times 2 matrix, so the middle 2 number are the same, so I can square it, I can times the same thing. So, but again, I will use the row for the first one and column for the second one. So do the same operation, doesn't matter whether they're the same matrix or not. I times them, I get 5, negative 6, negative 6, and 17. Okay, 5, negative 6. Okay. Okay, we have the same thing. Okay, but x squared, x times x. X is a 2 times 1 matrix. X is 2 times 1 matrix. The middle 2 numbers are not the same, so they can't be evaluated. So it's undefined for that one. So you can't do any operations here. Okay, so x squared doesn't exist. Okay, it doesn't exist. So we have undefined here. Any more questions for today? It's basically calculations for matrix. Okay.
That's what's up.